Hello and welcome to part 2 of the Unit 7 Algebra Review. In this one we'll be doing sections 3, 4, 5, and going over the flashback review questions. So, the first question, so section 3 says simplify each polynomial by multiplying or dividing. So what we need to do is we need to multiply this out. I'm sorry. So, and you've probably been taught a few different ways to do these by your teachers, either by foiling or doing the Punnett square. And I will demonstrate both. So if you do the Punnett square, it's 3x minus 2 and negative x plus 4. That'll give me negative 3x squared plus 2x plus 12x minus 8. If I do the FOIL, it's first outside inside last. But what you will see is that you wind up with the same numbers either method. So which method should you use? The method that works best for you. If you do the square, then you write it out like this, and then the only thing we have left to do is combining like terms. And generally the middle two terms will be the like terms. And so we'll have negative 3x squared plus 14x minus 8. All right, so this one is distributing. You're distributing this piece into the other two. Here, let me make this. So I will be distributing this to each. So it's multiplying each one. So 4 times 3 is 12. X squared times x cubed is x to the 5th. And y times y to the 4th is y to the 5th. And that was the first one. And we'll just do that. Then the second one is 4 times negative 5 is negative 20. And x squared times x is x cubed, y. Because the y doesn't multiply with anything over here, exponent doesn't change, and we get that. Once again, we're just applying the monomial rules that we went over in section 1. So, distribute 3y x to the negative 5 minus 9y squared. But in our final answer, we cannot have a negative exponent. And so we will get that. Now they're asking us to divide. And the easiest way to divide is when you're dividing a polynomial by a monomial, just break it into pieces. So this will be 3xy squared over y to the 6th plus y to the 6th over y to the 6th. Once again, applying the rules of exponents, this will be 3x, subtract the exponents, y to the negative 4, plus, remember, any number divided by itself is 1. And so I'll end up with 3x over y to the 4th plus 1. And there's my answer. For E, break it into pieces. 4x to the 3rd over 4x to the 3rd minus 12x to the 7th over 4x to the 3rd. Any number divided by itself is 1. 12 divided by 4 is 3. Subtract the exponents, and I get x to the 4th. F is just the same problem as before. They just wrote it as a division. Remember, 1 divided by 4 is the same as 4 like that, which is the same as that. So we're just going to write this out in pieces again. And we will get 3x squared plus 2x plus 1. We finally get another foiling problem. So we can do the Punnett square. Six x plus 1, 6x minus 1. That'll give me 36x squared, 6x minus 6x minus 1. Or, if you want to do it by foiling, 36x squared minus 6x. I'm sorry, I did that backwards. I should have done outside, inside plus 6x. Last. Wrong. I haven't used blue yet. Minus 1. Once again, you get the same terms either way. Now, it's negative 6x plus 6x, though, cancels because something minus itself is 0, and I'll end up with 36x squared minus 1. For this last one, this is just really similar to problems C and really similar to question C, but much easier. So the question is, how do you determine the area of a rectangle? And area of a rectangle is length times width. Well, the length of the rectangle is x, and the width is 3x minus 15. So all they're asking us to do is multiply these two things together, and we'll get 3x squared minus 15x. And that's it for section 3. Section 4 is playing with tiles. Some of you weren't taught this in class, but it is something that eventually will appear on the SOL. So this is an x squared, this is an x squared, this is a minus x squared, this is a minus x, x, 1, 1, 1, 1, minus 1, minus 1, minus 1. And this is pretty easy to deal with because anything that has an opposite cancels out. And all we're left with is x squared minus x plus 1. For this one, what polynomials run it by the diagram? Now, if you didn't get the tiles, don't need to worry about it because you could still get this exact same problem by just foiling or Punnett squaring x plus 3 times x plus 2, which would give me x squared plus 2x plus 3x plus 6, which is x squared plus 5x plus 6. So that's our answer. But if we want to get it from the tiles, we can do that as well. That's an x squared, x, 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 1, 2, 1, 1. Those are all the ones. So there's a single x squared, there are 5 x tiles, and there are 6 single tiles. And you will see that the two answers are the same. For this one, draw the algebra tiles to represent this. So if you haven't seen this, it's really simple. It's x plus 4 times x plus 2. And then to get our answer, all we do is we draw the box. and then we draw lines anywhere there's a break. And then we just look at our shapes and say, okay, well, what fits there? Well, that's an x squared, that's an x, an x, an x, an x, an x, and an x, and a 1, 2, 3. So that'll be x squared plus 6x plus 8. But that's how you draw the model. And so that's section 4. Section 5 was scientific notation. Scientific notation, all we want to do is apply the rules of exponents and break it into pieces. Remember, the commutative property and the associative property say that basically when we multiply, order doesn't matter. And so what we'll do is we'll do 1.3 times 4.7 times 10 to the 4th times 10 to the 4th. Well, 1.3 times 4.7 is 6.11. And here the bases are the same, so we just add the exponents. And there's our answer. For this one, same thing. Is you get 6.0 times 3.2. Sorry, I got a stray mark there. Let's erase that so we're just perfectly clear. 6.0 times 3.2 times 10 to the negative third times 10 to the negative third. And so that'll give me 19.2 times 10 to the negative 6. But in scientific notation, we only have one place in front of the decimal place, so that when I move the decimal place 1, the exponent changes by 1. Incidentally, it is also possible to do these in your calculator. And I'll show you that real quick. Is if you have your calculator, let's just see here. Bring the calculator back up. Initially, if we go into mode, which is right here on the calculator, it brings up the settings. And the settings here are just like the settings on your iPhone. You want to turn off Bluetooth, Wi-Fi, whatever. Here, these are the settings for the calculator. And so by default, the calculator is set to normal mode. However, I can change that to scientific notation. And then when I quit and get out of the settings, then when I start typing in numbers, all the numbers are turned into scientific notation. And what's being written here is really 10 to the second power. That's what that E means. So 300 becomes 3 times 10 to the second power. So then I can just type in my original problem, 6.0 times 10 to the negative third. I guess they had it all in parentheses, didn't they? So we'll type it exactly like it looks. Times 3.2 times 10 to the negative 3. We hit enter, and there's our 1.92 times 10 to the negative fifth. So whenever you see this E, that means that it's scientific notation. Now, if you ever type in a real number, a regular number, and it starts doing weird stuff like this, this means it's in scientific notation setting, and you have one of two choices. You can either go back into mode and turn scientific notation off, or you can reset the calculator. If you ever get stuck, remember, you can always reset the calculator by going second plus 7, 1, 2. And then everything will go back to the way it came from the factory. Okay. So all we have left are the flashback review questions. So write the equation of a horizontal line passing through the point 2, 4. So horizontal means a line going like this. And the equation of all horizontal lines are y equals. And this line goes through 5, so if the horizontal line passes through 2, 5, then the horizontal line is just y equals 5. A vertical line is going to go like that, so it's going to pass through the x value. And it's just going to be x equals -1. A lot of times we get so caught up in slope and y-intercept we forget the very simple ones of vertical and horizontal lines. Solve the equation below for w. So what they want you to do is solve this literal equation for w. So we need to get w alone. So we would subtract 2l from both sides, and I get p minus 2l equals 2w, because I subtracted 2l from both sides. 2l minus 2l cancels, and I get p minus 2l. Then I'm going to divide both sides by 2. And I'll get w equals p minus 2l over 2. Now, most people would be okay to leave that like that. If you wanted to, you could also write it as p over, you could break it into 2 pieces like we did earlier and get that. But either one of these answers would be correct. This one should be a piece of cake after what we've been doing this unit. You just distribute it. -3x plus 15. This one we're going to have to do in 2 steps because we only distribute to what's inside the parentheses. So this will be -5x plus 35, but we cannot forget the plus 3 at the end. And so that'll be -5x plus 38. And then same thing for this one. We're only distributing the -1 to those. So this is x minus 4x plus 4. And so I'll get -3x plus 4. And for the last flashback question, it says, what is the slope of the line represented by this? Now remember, slope is y, if slope-intercept form is y equals mx plus b, where m is the slope. So we need to get y by itself. Well, y is not by itself. So we're going to subtract 1/3 x from both sides. And I'll get 4y equals -1/3 x plus 8. Then we're going to divide both sides by 4. Now, I know this is going to hurt some people's heads a little bit, but -1/3 divided by 4 is -1/12. And you can either do that on your calculator, or you can remember that dividing is the same as multiplying by the reciprocal. So the slope would be -1/12. So that's the second video. If you have any questions on this or the first video, please bring them to class and ask your teacher before you start the test. Good luck.